Definite integrals were referred to in an earlier video. You now understand how to find indefinite integrals by integrating given integrands. But now we want to look at definite integrals. Now, if you're integrating a function with respect to, let's say, a function of x with respect to x, you're going to get a function of x. Sometimes you get a constant, but you can always write it as a function of x. So let's just say you're integrating a function of x with respect to x and you get a function of x. There are no limits in your integration, so the result is an indefinite integral. In this case, we're integrating a function of x with respect to x, but there are limits. The result is known as a definite integral. So if the indefinite integral of a function is g of x, if you want to find the definite integral of that function with the upper limit b and the lower limit a, the definite integral is simply g of b minus g of a. That simply means g of x is a function. All you have to do is replace x with the upper limit b, then minus the same function g of x, but you now replace x with a. This is going to make sense shortly. So let's assume that f of x is 3x squared. You need to make this an integrand, so integrate this integrand. So I'm integrating f of x, 3x squared, with respect to x. What do I get? I get x cubed plus an arbitrary constant, c. So g of x here is this x cubed plus c. As you can see, it's a function of x. So if you compare this expression or equation to this equation, you can see that f of x is 3x squared and g of x is x cubed plus c. So g of x is the indefinite integral of f of x. So consider this second scenario where we're finding a definite integral of the integrand. So imagine I'm integrating 3x squared with respect to x, with the upper limit b being 2 and the lower limit a being 1. All you have to do is take your indefinite integral, which is g of x in this case, and then replace x with the upper limit, which is 2 in this case, then subtract the indefinite integral where x has been replaced with the lower limit 1. So the upper limit a, which is 2 in this case, x is replaced with the upper limit of first, and then x is replaced with the lower limit, and then you subtract the indefinite integral in which x has been replaced with the lower limit from the indefinite integral where x has been replaced with the upper limit. In our case, g of x is x cubed plus c. So replacing x with 2 in x cubed plus c gives 2 cubed plus c. And we have this minus the indefinite integral g of x when x is 1. So replacing x with 1 gives 1 cubed plus c. And this gives 8 plus c minus 1 cubed minus c, which is 8 plus c minus 1 minus c, which is 8 minus 1 plus c minus c, which is 7. What's c minus c? That's 0. So it gives 7. So we have a definite integral. The definite integral of 3x squared with the upper limit 2 and the lower limit 1 is 7. Now the notation, now instead of writing g of b minus g of a, we can just write this, g of x b a, and that's understood to equal g of, well, x equals b minus g of x equals a, and you can just write that as g of b minus g of a. And this simply means in the function replace x with b, and this simply means in the function replace x with a. So I can rewrite our problem out. I'll just use this region. So we had we have to integrate 3x squared with respect to x with the limit 2 and 1. And that's equal to the indefinite integral which we obtained earlier as x cubed plus c. This is now the notation you use. You put the upper limit and you put the lower limit below. And then you can replace x with the upper limit at first, and that gives 2 cubed plus c. And then you put a minus sign and replace the variable with the lower limit, and you get 1 cubed plus c. And you get the same result, 8 plus c minus 1 minus c, which is 7. So familiarize yourself with this notation. I'm going to use it in the examples that are to come. But the key thing to note is, once you know how to find the indefinite integral of an expression, it's a simple procedure to determine the definite integral, because all you need to do is just replace the variable with each limit in turn, and you just have to follow the specified order as given by this expression here in red. So we're just going to take some more examples so that you can have more practice. So here's an example. We need to evaluate the following. The first expression says integrate x with respect to x with the upper limit of 20 and a lower limit of 5. So what do? You find the indefinite integral at first. So you just simply solve this, and that gives x squared over 2 plus an arbitrary constant. So that's what we're going to write here, x squared divided by 2 plus an arbitrary constant. But then we have limits. The upper limit goes here and the lower limit goes here, and this simply means replace the variable with the upper limit, and that gives 20 squared divided by 2 plus c, then minus what you get when you replace the variable x in this case with the lower limit, which is 5. That's 5 squared divided by 2 plus the arbitrary constant c, and that is equal to 400 divided by 2 plus c minus 25 over 2 minus c. Don't forget a minus sign right in front of a bracketed expression. Each term changes sign, which gives 200 plus c minus 25 over 2 minus c, which is equal to 200 minus 25 over 2 plus c minus c. As you can see, c minus c is going to be 0, so it cancels out, and that gives 375 divided by 2. This expression, we need to integrate something with respect to x with the upper limit of 4 and the lower limit of 3. So just in case anyone's confused at the moment, integrating respect to x is the same thing as integrating 1 dx. Same thing as 1 times dx, and 1 is the same thing as x to the 0. So this expression is the same thing as integrating x to the 0 with respect to dx with the upper limit of 4 and the lower limit of 3. So naturally what you do is you find the indefinite integral at first. In this case, that's x to the 0 plus 1, which is x to the 1 divided by 1 plus an arbitrary constant, and then use these square brackets, place the upper limit here, the lower limit here, substitute the upper limit, so replace x with 4, and that gives 4 plus c, put a minus sign, don't forget this minus sign, and then replace x with 3, and that gives 3 plus c. So this is equal to 4 plus c minus 3 minus c, which is equal to 4 minus 3 plus c minus c, which is equal to 1 plus 0. C minus c is 0. Now at this point, because you've seen this a couple of times now, I can now tell you that arbitrary constants always cancel out. So in integration problems where you're having to find a definite integral, arbitrary constants always cancel out. After a lot of practice, you'll find that you don't even have to write down the c, you'll just jump straight to the answer without the arbitrary constant. The way I like to express problems, well, definite integral problems, is as follows. So I have to find the definite integral of some function, in this case it was x to the 0, with respect to x, with the upper limit 4 and the lower limit 3. I like to first say, okay, I need to find the indefinite integral of my integrand, in this case as x to the 0, and then I need to substitute the limits in turn. So what you do here is just find the indefinite integral, which is x plus c, which is x plus c, and then I have my 4, my 3, and I substitute them in turn. So I have 4 plus c minus 3 plus c, which when I simplify gives 1. So I'm going to represent my problems in this form from now on. This expression needs to be evaluated, and it says integrate 3x cubed minus 2x with respect to x, with the upper limit 3 and the lower limit of 0. So what do? You find indefinite integral first of the integrand. The integrand is this expression here, right in front of dx. Find the indefinite integral, and then substitute your limits. So let's focus on what's inside the square bracket at first. We need to find the indefinite integral of this expression. So that gives 3x to the 4 divided by 4 minus 2x squared divided by 2 plus the arbitrary constant. Now you can have done it in stages where you integrate 3x cubed first, have an arbitrary constant c1, not the minus sign, integrate 2x first, have an arbitrary constant c2, and then combine the two arbitrary constants to give c, but I've skipped all those steps. This is something you can do and compare your answer with. And then we move on to the last step, which is just replacing the variable x with the upper and lower limit. As you can see, once you know how to obtain indefinite integrals, then obtaining definite integrals is a piece of cake. So I'm going to replace x with 3 now. So that gives 3 times 3 to the 4 divided by 4 minus 2 times 3 squared divided by 2 plus the arbitrary constant minus 3 times 0 to the 4 divided by 4 minus 2 times 0 to the 2 divided by 2 plus an arbitrary constant. This gives 3 to the 5 over 4 minus 2 here 1, 2 here 1, 3 to the 2 plus c. And then let's see what happens in this expression. 0 to the 4 is 0. So 0 times 3 is 0. 0 over 4, 0. So this goes to 0 minus 2 times 0 squared. 0 squared is 0. 2 times 0 is 0. 0 divided by 2 is 0. So this goes to 0. So we're just left with the arbitrary constant. So essentially what we have here is minus 0 plus c, which is the same thing as minus c. So this term, well, we have this minus c, which is equal to 3 to the 5 over 4 minus 3 squared plus c minus c, c minus c 0. Arbitrary constants always cancel out when you're finding definite integrals. And that's equal to, which is equal to 207 divided by 4. So that's a 0. So here we have another expression we need to evaluate. So we need to integrate 5 over 2x to the 4 dx with respect to an upper limit of u. So use a constant here, not a variable, and v here is lower limit, is also a constant. So I can just rewrite this. I just need to find the indefinite integral of the integrand and then substitute the limit in the right order. So the upper limit is u, the lower limit is v. I can write 5 over 2x to the 4 as 5 over 2x to the minus 4 dx. Use the upper limit, v is the lower limit, and this is the same thing as, well, integrating the integrand gives 5 over 2x to the minus 4 plus 1, which is minus 3, all divided by minus 3, which is same thing as multiplying by 1 over minus 3, plus an arbitrary constant. Then all of this square brackets with the limit outside, and I can write this as minus 5 over 6 x to the minus 3. And then all you have to do is substitute the upper limit at first. So replace x with the constant u, and that gives minus 5 over 6 u to the minus 3. Of course, there's an arbitrary constant here. It cancels out, which is why I ignored it, but we need to put it, to be honest. We need to put it to make everything, to write down all our steps. So replace with the upper limit. Now I need to replace the variable with the lower limit v. But of course, the minus sign here must not be forgotten. So minus 5 over 6 v to the power of minus 3 plus the arbitrary constant. And this is simply minus 5 over 6 u to the minus 3 minus 5 over 6, so that becomes plus 5 over 6 to the v minus 3. The arbitrary constants cancel out, so I would like you to expand this bracket, remove all the brackets appropriately, and simplify and check that you get this. I can always factorize this to give 5 over 6 into minus u to the minus 3 plus v to the minus 3. And I can further rewrite it here as 5 over 6 minus 1 over u to the 3 plus 1 over v cubed. So just rewrite it, just make it neater. This is 5 over 6. Have it as 1 over v cubed minus 1 over u cubed. I'll stop here. So we need to evaluate this expression. We need to integrate the integrand, which is this, with respect to x, with an upper limit of 5 and a lower limit of minus 2. So first thing to do is to expand this expression. From the expansion videos in the algebra course, you know that x squared times x minus 1 is x squared times x, which is x cubed, minus x squared times 1, which is x squared. So what we're doing is integrating x cubed minus x squared with respect to x, upper limit of 5, lower limit of minus 2. And this is equal to, so let's first find the definite integral of our integrand, which is now x cubed minus x squared. This is our indefinite integral. Integrating that gives x to the 4 over 4 minus x cubed over 3 plus an arbitrary constant. And then have an upper limit of 5, a lower limit of minus 2. So I'm going to replace x with 5. Doing that gives 5 to the 4 divided by 4 minus 5 to the 3 divided by 3 plus c minus, now I'm going to replace x with the lower limit, which is minus 2. So that gives minus 2 to the power of 4 divided by 4 minus 2 to the power of 3 divided by 3 plus the arbitrary constant, all in a bracket. So I'm just going to go over this logo here, and that gives 5 to the power of 4 divided by 4 minus 5 to the 3 divided by 3. I'm not going to write down the arbitrary constant because I know it's going to cancel out. I know that this plus c is going to cancel out with this plus c here, because it's going to be c minus this plus c. and then I'm going to have minus, so minus 2 to the 4, 2 times minus 2 times minus 2 is 4, times minus 2 is minus 8, times minus 2 is 16. So I have 16 over 4, and then I have minus, well, minus 2 cubed is what? Minus 2 times minus 2, which is 4, times minus 2, which is minus 8. So minus 8 over 3 gives plus 8 over 3. The arbitrary constant cancels out, so I don't want to bother with it. I can finally write this as 5, well, not finally, but I can write this as 5 to the 4 over 4 minus 5 to the 3 over 3 minus, what's 16 over 4? That's 4 minus 8 over 3. And now we can use a calculator to simplify this to give our definite integral, which is equal to 1295 divided by 12. So integrating x squared times x minus 1, our integrand, with respect to x, with the upper limit of 5 and lower limit of minus 2, gives definite integral, which is 1295 divided by 12.